If a quasi-star were to enter the solar system, the consequences would be dramatic and potentially catastrophic due to the quasi-star's extreme characteristics. Quasi-stars are theoretical objects that are hypothesized to have existed in the early universe and could be significantly more massive and luminous than typical stars. Here's a detailed look at what might happen if such an object entered our solar system. ***1. Gravitational disruptions. The quasi-star's immense mass would have an immediate and profound gravitational effect on the solar system. The gravitational pull from a quasi-star, which could be thousands of times more massive than our Sun, would cause substantial perturbations in the orbits of planets and other celestial bodies. This could result in orbital instability. The orbits of the planets, including Earth, would be altered. Some planets could be pushed into highly eccentric orbits or even be ejected from the solar system entirely. The gravitational perturbations could also lead to increased collisions between celestial objects. Disruption of moons and rings, moons orbiting planets and ring systems around planets could be destabilized. The altered gravitational forces could lead to the breakup or ejection of moons, and ring systems could be disturbed or dispersed. ***2. Radiative effects. A quasi-star would emit extraordinarily high levels of radiation, including intense ultraviolet UV light, X-rays, and gamma rays. This radiation would have several serious effects. Atmospheric damage. The increased radiation would strip away Earth's atmosphere, reducing its ability to support life. The loss of atmospheric protection would expose the surface to harmful solar and cosmic radiation, leading to severe health risks for living organisms. Climate change. The additional heat from the quasi-star would dramatically increase temperatures on Earth, leading to extreme climate changes. This could result in the melting of polar ice caps, rising sea levels, and widespread environmental devastation. Photosynthesis interruption. The increase in radiation could interfere with photosynthesis, crucial for plant life. Disruption of this process would impact food chains and agriculture, leading to potential food shortages and ecosystem collapse. 3. Impact on solar dynamics. The presence of a quasi-star would also affect the Sun and its activity. Orbital dynamics. The gravitational interaction between the quasi-star and the Sun could alter the Sun's orbit around the center of the Milky Way galaxy, affecting its galactic trajectory. Solar activity. The presence of the quasi-star could influence the Sun's own activity, potentially affecting solar flares and coronal mass ejections. The increased radiation might lead to changes in the Sun's energy output and its interaction with the solar wind. **4. Effects on the solar system structure. The structural integrity of the solar system would be compromised. Planetary collisions. The altered orbits could lead to collisions between planets or between planets and asteroids. This would cause significant damage and potentially lead to further destabilization of the solar system. Disruption of the Kuiper belt and Oort cloud. The quasi-star's gravitational influence would extend to the Kuiper belt and the Oort cloud, potentially sending comets and other objects into the inner solar system. This could increase the frequency of impact events. **5. Long-term consequences. The long-term effects of a quasi-star's presence would depend on several factors, including how long it remains in the solar system and its eventual fate. Potential for new equilibrium. If the quasi-star were to exit the solar system after causing initial disruptions, the solar system might eventually settle into a new equilibrium, though it would be drastically altered from its original state. Possible collapse. If the quasi-star remained for an extended period, the solar system could undergo significant changes or even collapse into a new configuration. The gravitational and radiative effects could lead to a complete restructuring of the system. **6. Impact on Earth and human civilization. The immediate and long-term impacts on Earth would be severe. Extinction risks. The combination of atmospheric loss, extreme temperatures, and radiation exposure would create a hostile environment for life. Human civilization, along with many species, would face existential threats. Technological and societal collapse, the destruction of infrastructure, disruption of essential services, and collapse of ecosystems would lead to a breakdown of modern civilization and society. In summary, the entry of a quasi-star into the solar system would have catastrophic consequences, including gravitational disruptions, intense radiation, and severe climate changes. The solar system's structure would be profoundly affected, with potential risks to the stability of planetary orbits and the survival of life on Earth. The long-term outcomes would involve significant alterations to the solar system, with potential scenarios ranging from a new equilibrium to complete collapse.